Hello everyone. In this video, we are going to talk about dummies and graphs. So here is the Pioneer mobile robot, and I added a dummy to it. Now, what is a dummy? We're going to talk about it. And then I plotted the XY position of the dummy, which is attached to the robot. It's a child of the robot. So the position of that is the position of the robot. So we can see that when I make this guy go on a circle, you clearly, let me run it for you, you clearly can see that the XY graph does actually show a circle. Okay, so you can see that now. It might look like an ellipse here because of the aspect ratio, but if you look at the dimensions, you should be able to see that here. And here is X and Y separately versus time, which you can see kind of sine and cosine functions. Okay, so how do we do that in CoppeliaSim? So the first thing is this guy here, right, which is like a point, like a sphere. This guy is what we call a dummy. So what is a dummy? If we look at the documents of Coppelia, you can see that the dummy is kind of like a point. It's the simplest object you can have. It's a single point that has an orientation. And the major use of that is a reference frame. So it's a point of interest that you want on the robot to track its position, orientation, or anything, right? So because that mobile robot has lots of points, and different points have different XY values. So here I look at this specific point that I want. I go ahead and add a dummy to it. And the way you do it is simply right click and say add and then say dummy. And you see right now it has created a dummy here for you, but this is too small of a dummy. So if you can barely see anything, it's a point. But if you want to make it bigger, you go here and change the size of it. Let's make it like 10 times bigger. And you can, for instance, make it a green dummy or any color that you like. You can change shininess of it. So there are all sorts of controls like any other object, okay? So here we go. I make it like a green big dummy, and you can see that right here. It's a sphere basically, and you can move it up and down like anything else. And the dummies, like any other objects, you can have them collidable, detachable, measurable, and so on. Okay, but they are not, of course, dynamic or respondable because they are a point. They are not a rigid body. But you should be able to just basically register the state of collision for them, and then you can detect them with proximity sensors, and you can measure their minimal distance from another object or dummy. So they have lots of different applications, but as I said, it's really a single point or a reference frame. So here I have added that to this robot, and I put it right on the top of the robot. And to make sure it does move with the robot, I made it a child of the robot. As you can see, this dummy is underneath the robot, okay? So however the robot moves, the dummy moves with it. And as I showed you in one of my previous videos, in the script of this Pioneer, when you bring it in, it moves in a straight line and it falls off of the edge of the scene or the chessboard basically here, the plate. But if you change one of the speeds of the wheels to be bigger than the other one, then it goes in a circle. So that's the only change I did make. One of them goes 40% faster than the other one, the right faster than the left. So it is going to go and turn left all the time. And so that is the dummy and the creation of that. Now, to register the X and Y position of this dummy, I need to create a graph. And the graph, you can add it as a child of the dummy, or you can just add it to the scene. Most of the time, a graph is simply added to the scene. The graph does not need to be the dummy, the child of the dummy or the robot. The graph could be just a child of the whole scene. So you see this graph, I added it as a child of the scene, and I put it on this corner here, and I made it invisible, okay? Because when you create a graph, let me show you, it adds an object for you, right? Look at that. So it basically adds this thing for you. So if you want to get rid of that, you can simply go ahead and make it invisible, right? So we go here, go to object and get rid of this tick, and you can basically make it visible or invisible. So I put it on the corner, made it invisible, out of my way, and it doesn't matter where it is, whether it's visible or not. The important thing is the script that you write for it to get the stream of X and Y data from this dummy and plot them here. That's the major thing. By the way, when you create a graph, as you just saw, it comes with this script already. Let me show you again. So when I create this graph, look, it has this script already, and this script has only one line of code. The require command that creates this window. So my recommendation is, if you want to get the stream of XY data from any object and you want to show it in that, do not change this script 0, leave it as is, create a new script for this graph, right? So create a new, right click on the graph and say add, and create a new script, which I did here as a non-threaded in Lua. Create a new one, and you see even their color are different. So this kind of darker one is to create the window. This brighter one is to get the data and do the plot. So if I merge them together, and if this line does not come in the first line of the code of the script, then you will not see this window. This window will disappear. So my recommendation again, do not get rid of the original script, a new one, and put all your code in that. So if we double click here, this is the code. First we create the sim, then we create the graph handle for our graph here using get object handle, and you see I called it graph with capital G. Then get the dummy handle, and here I use backslash, so because dummy is a child of the Pioneer PD3X robot. So here I say go and grab the handle of that. Then I use this function or method called add graph stream, and pass it the graph handle, pass it with underscore X or Y, the dummy X coordinate or Y coordinate, pass it the unit, and which is meters here, and then the option for the stream. 0 is the default mode, 1 means the data is not stored, it's for real time, and 2 means the data is stored in a cumulative manner. So once you create the X stream and Y stream in the initialization function, now it is time for you to create the graph curve. And the graph curve needs a bunch of data to be passed to, a bunch of inputs to be passed to it. What are these? The first one is the graph handle. The second one is basically the title for the plot. So you see it says dummy XY path. That is exactly this guy here. Okay? Then dimension. What is the dimension of the signal that you're passing? So here you're passing the stream of X and Y combined, and you see I'm combining them with the braces. So the dimension is 2. Then the stream IDs are the X stream and the Y stream that I already created, just combining them into a 2-dimensional signal with braces. Then I need to give it default values. So the default are 0, 0 for the beginning. The unit is meters. The option here is 0 for the default mode, and these points are all going to be connected with solid lines. Then color in RGB, so I use 100, which means red, and then curve width, which is 1 unit. If you want to make it thicker, go ahead and change it, for instance, to 2 units or anything that you like. And then you pass all of them to it, and you create a curve ID. Now that you have the stream and the curve ID, you are ready to start the sensing function. In the sensing function, you use this method called getObjectPosition. And you give it the dummy handle, and it gives you the position, which is the stream of the data. Okay? And then now you use the next function, which is called setGraphStreamValue. And you pass to the graph handle for the X stream element 1 of this position vector. And for the Y stream of that, you pass to it what? position element 2, because this position is similar to the stream ID. It's a two-dimensional vector where the first element is x, the second element is y, and this function will get the data in pose and pass them to the x stream and y stream of the graph handle, and that is gonna update this graph and show you what you see here. And you might be asking, what is this -1? This -1 means relative to the word frame. So option -1 means relative to world frame. Otherwise, use basically something like this. So otherwise, instead of this -1, you have to say robot handle or any other thing handle. Okay, so this is the with respect to which frame. Okay, so let's call it frame handle. Okay, so this is the option for that. And here for this 0, let me also show you. So option 0 here means default mode. Option 1 means data not stored, which means real time plots, and option 2 means cumulative storage of data. Okay, by the way, if you want to comment out several lines in Lua instead of using 2 dash lines, what you can do is to use 2 dash lines and then 2 brackets. And then at the end of the block, use another 2 brackets and close it. So now you have a block of comments instead of putting the double dash behind each and every one of the lines. Okay, so that can basically do a block of comments for you and make the commenting a little bit more interesting. Just make sure that there is no space between the dash lines and the double brackets here. So there we go. This is your code, right? This is all of your code. And now we are going to run it again so we can see the result. Now I changed the line width to 2, so it's a little bit thicker, not super thicker, but you can clearly see that I could get the stream of my data and I could get the XY graph as well as X versus time and Y versus time. So hopefully this video was useful to you, and I'm gonna see you in the next lecture. Thank you.